Burial, burial, burial is my school. Best education reservoir for young learners just like me. Burial,
Good morning everyone, and welcome once again to Burial e-learning. Today we'll be having a class for SS1 mathematics with the topic on the board surface area and volumes of shapes. Surface area and volumes of shapes. Now for this topic we will channel our discussion mainly to surface area and volumes of three-dimensional shapes. For example, we have cubes, we have cuboids, we have cones, we have tetrahedrons and all of that. We're looking at the different surface areas and volumes. We'll start with a cube and a cuboid. As you already know, a cube has equal faces. And equal edges. For our cube, each of the face is a square. Each face of our cube is a square. And we have that our area of a square is given as length squared. Because for a square, all the sides are equal. We have length, all the sides are equal. So we call each of the sides length. And we say the area of a square is given as length squared. So for a cube having 6 faces, the area will be given as 6L squared. Because it has 6 faces, the area will be given as 6L squared because each of the face is square shaped. The volume of a cube is given as length times length times length. As we said earlier on, each of the faces is a square and a square has equal sides. So we call each of the sides length. So the volume of our cube is length times length times length, which is equal to length cube. As we already know, a cube and a cuboid share similar properties. So we have our cuboid on the board having 6 faces just like our cube, having 6 faces, and we know that each of the faces is a rectangle. Each face of the cuboid is rectangular shape. You have a rectangle, and so on and so forth. So the area of our cuboid, is given as 2 into brackets length breadth plus length height plus breadth height. The area of our cuboid is given as length times breadth plus length times height plus breadth times height. We multiply everything by 2 to get the area of our cuboid. And the volume is given as length times breadth times height. Length times breadth times height. For our cuboid, as I said earlier on, the edges are not the same. The face is a rectangle, and the formula for finding the area of a rectangle is length times breadth. So for volume, we have length times breadth times height. That's the volume of a cuboid, while area will be length times breadth plus length times height plus breadth times height. You multiply everything by 2 to get the area of our cuboid. Okay, we have an example on the board. A car petrol tank is 0.8 meters long, 25 cm wide, and 20 cm deep. What is the volume of the tank? Then how many liters of petrol can it hold? Yeah, before we solve this, let's take note that the car petrol has a different length with a width and a depth. And so obviously it should be rectangular shaped. So for us to find the volume of the tank, we use the formula for volume. Length times breadth times height. Now, we say 25 cm wide. Wide here also means breadth. You can either call it breadth or width. So it's something, and deep here. Depth also can be used to replace height. So you can call it depth or height. So our length is 0.8 meters. Our breadth or our width is 25 cm. and our height, which is the same thing as our depth, is 20 cm. But our length has a different unit in meters. Our length is in meters, so for us to do this, multiply this through, we convert our meters to centimeters. We know that 1 meter is equal to 100 centimeters. So 0.8 meters to centimeter will give us 0.8 times 100 centimeters. And that will give us 80 centimeters. So our length is now 80 centimeters. We now find our volume. Our volume is given as length times breadth or width times our height, which is the same as our depth. So our length is now 80 centimeters times our breadth of 25 centimeters times our height or our depth of 20 centimeters. We now multiply through. If we multiply this, 80 times 25 should give us 2,000, then times 20 gives us 40,000 centimeter cube. 40,000 centimeter cube. 80 times 25, if you multiply using your calculator, that should give us 2,000. Then times 20 will give us 40,000 centimeter cube. So our volume of that tank, the volume of that tank is 40,000 centimeter cube. Now we are asked how many liters of petrol can it hold? How many liters of petrol can it hold? Now, any container at all that whose volume is 1,000 cm cube can hold 1 liter of liquid. Any container whose volume is 1,000 cm cube can hold 1 liter of liquid. It therefore means that 1,000 cm cube is equivalent to 1 liter. So we now have a volume of 40,000 cm cube. For us to convert to liters, we divide 40,000 divided by 1,000. 40,000 divided by 1,000. We have 3 zeros to cancel 3 zeros, and we are left with 40 over 1 is 40. So the tank, the car petrol tank, can hold 40 liters. It can hold 40 liters of be it petrol or any liquid at all. Because we say that 1,000 cm cube is 1 liter. We now convert our volume, 40,000 cm cube, now to liters. And in conversion from cm cube to liter, we divide by 1,000. And that gives us 40 liters. So the car petrol tank can hold 40 liters of petrol. Let's solve another problem on the board. You have calculate the surface area and volume of a cube of length 7 cm. Calculate the surface area and volume of a cube of length 7 cm. Now we were given the formula of calculating the area of a cube. The formula of calculating the area of a cube to be 6 times length squared. Since we say that the cube has 6 faces and each of the face is a square, and the formula for area of a square is length squared, so we multiply that by 6 to get the area of our cube. So having known that, we are given a length of 7 cm. We are given the length of 7 cm. So our area will give us 6 times 7 squared. 6 times 7 squared. That's 6L squared, 6 times 7 squared. And that will give us 6 times 49. 6 times 49. We multiply this together, we get 6 times 49 gives us 294 centimeters squared. 294 centimeters squared. The area of our cube is given as 6L squared. 6L plus 6 times length squared. And we have our length to be 7 cm. So 6L squared will give us 6 times 7 squared. So 7 squared is 49. Now 7 times 7, then times 6 will give us 294 centimeters squared. So the area of our cube of like 7 cm is 294 centimeters squared. We are also to find the volume of that cube. We are also to find the volume of that cube. And we have volume of cube is given as length times length times length. Since we know that all the faces are the same, all the edges are the same, so length times length times length gives us length cube. That is the formula for finding the volume of a cube. So, and we have our length of 7 cm. So we say 7 cm times 7 cm times 7 cm. 7 times 7 gives us 49. 49 times 7 gives us 343 centimeter cube. So the volume of that cube is 343 centimeter cube. Take note our area is in square, centimeter square. When we have our length in centimeter, we have centimeter square as our unit. And for our volume, when we have our length in 7 centimeter, our volume should be in centimeter cube. For area, we have square. For volume, we have cube. Let's look at the shape we have on the board. We have to calculate the surface area and volume of the shape below. And we know that this shape is a cuboid because it has different length, breadth, and height. So it is a cuboid. So we have to calculate the surface area of the cuboid and its volume. So we apply the formula for finding the area of a cuboid. Is given as 2 into bracket length times breadth plus length times height plus breadth times height. 2 into bracket length times breadth plus breadth times height plus length times height. We have our length here to be 8 cm, our breadth to be 5 cm, and our height as 3 cm. So we compute. We have 2 into bracket 8, that's our length, times 2, our breadth 5. Sorry, our breadth is 5. Then plus our length again 8 times our height is 3. Plus our breadth of 5 times our height of 3. Let's take it again. We have length times breadth plus length times height plus breadth times height all multiplied by 2. Now we have our length to be 8 and our breadth of 3. Sorry, 5. So we have 8 times 5 plus 8 times 3 plus 5 times 3. And multiply our result by 2. Now 8 times 5 gives us 40 plus 8 times 3 gives us 24 plus 5 times 3 gives us 15. So 40 plus 24 gives us 64. 64 plus 15 we have 79. We have 2 times 79. So we multiply 79 by 2 and we get 158 centimeters square. So the surface area of our cuboid with length, breadth and height of 8 cm, 5 cm and 3 cm respectively is 158 centimeters square. We have calculated the surface area of this shape and we have the formula on the board. 2 into bracket all of this. Since we have this in bracket, we first add up, simplify this, then we multiply our result by 2. We are given a length of 8 cm, a breadth of 5 cm and a height of 3 cm. So we now compute. We have length times breadth here, that's 8 times 5 we have on the board, plus we have length times height, that's 8 times 3 we have it on the board, plus breadth times height, that's 5 times 3 on the board. Now 8 times 5 gives us 40, 8 times 3 gives us 24, 5 times 3 is 15. We add up. 40 plus 24 is 64, plus 15 we have 79. And multiply 79 by 2 we get 158 centimeters square. Take note that we are looking for surface area and it should be in centimeters square since we have our dimensions in centimeters. So we're now going to find the volume of the shape. And we are given the formula for volume of a cuboid as length times breadth times height. Length times breadth times height. And we have our length, breadth and height on the board as 8 cm, times 5 cm times 3 cm. 8 times 5 gives us 40. 40 times 3 gives us 120 centimeter cube. Centimeter cube because we are dealing with volume. So we have the answer to 120 centimeter cube. The next we look at the surface area and volumes of cylinder. Surface area and volume of cylinder. You can see we have a cylinder on the board. We look at the curved surface area, the total surface area, and the volume. Now the curved surface area of a cylinder, curved surface area of cylinder is given as 2 pi RH. 2 pi RH, formula for finding the surface area of our cylinder. The total surface area now we have this cylinder on the board. It has we have the top and the base, and these top and base are circles. The top and base are circular shaped. This here is a surface area that has the formula 2 pi RH. Now we know that the formula for finding the area of a circle is pi r squared. This is pi r squared, and this is pi r squared. For us to now get the total surface area, we now add these two areas to our curved surface area. We have 2 pi RH as our curved surface area plus our area of these two circles. That's 2 pi r squared. Total surface area will be the curved surface area plus the area of these two circles. That's 2 pi r squared. So we now have 2 pi RH plus 2 pi r squared. We can factorize this to get 2 pi r into bracket h plus r. Since we have 2 pi r common to the both, so we now factorize to get 2 pi r into bracket h plus r. That's the formula for total surface area of a cylinder. Next, we look at the volume. The volume of a cylinder is given as pi r square h. Pi r square h. Because of area in this region where we have 2 pi RH, and the total surface area is the sum of the curved surface area and the area of these two circles. Since we have pi r square as area of a circle, for these two we now have 2 pi r squared plus our curved surface area, which is 2 pi RH. We factorize to get this 2 pi r into bracket h plus r, and the volume of a cylinder is given as pi r square h. Now look at how to use this and apply these formulas in solving problems. Look at what the question we have on the board. Calculate in terms of pi the total surface area of a solid cylinder of radius 3 cm and height 4 cm. B. Find the capacity in liters of a cylindrical well of radius 1 meter and depth 14 meters using 22/7 for pi. C. Calculate the volume of the cylinder below given its diameter of 14 cm and height of 4 cm. We'll start with the first. In terms of pi, the total surface area of a cylinder of radius, our radius is 3 cm, our height is 4 cm. And I gave us the formula for calculating the total surface area of the cylinder. We say it's 2 pi RH, that's top surface area plus the area of the two circles. We factorize this to get 2 pi r into bracket height plus our radius. That's the total surface area of a cylinder. So we have to calculate in terms of pi. So we have to find the value of pi for the first question. We have to find the value of pi for the first question. So we go 2 pi times our radius of 3 cm into bracket our height is 4 cm plus our radius of 3 cm. 2 pi r 2 pi times our radius of 3 cm into bracket h, our height of 4 cm plus our radius of 3 cm. 2 pi times 3 gives us 6 pi. 6 pi into bracket 4 plus 3 cm gives us 7 cm. 4 plus 3 gives us 7 cm. So we now have 6 pi times 7 cm. 6 times 7 gives us 42. So we have 42 pi cm squared. 42 pi cm squared. Calculate the total surface area of a cylinder in terms of pi. We have a radius of 3 cm and a height of 4 cm. And we apply the formula that has been given. 2 pi r, we have 2 pi times 3. The reason we're not using 22 over 7 is because we have to calculate in terms of pi. So we have 2 pi times 3 into bracket our height of 4 cm plus our radius of 3 cm. So 2 pi times 3 gives us 6 pi cm. Now into bracket 4 plus 3 gives us 7 cm. 6 times 7 is 42, so we have 42 pi centimeter squared. That's our total surface area of the cylinder. The second one, you have to find the capacity in liters. The capacity in liters of a cylindrical well of radius 1 meter and depth. And I say depth is the same as height. So depth of 14 meters. And our pi is given as 22 over 7. We have to find the capacity in liters. Before we find the capacity in liters, we must first find the volume of that cylinder. And the formula for volume we say is pi r squared h. We must first find volume before we can find the capacity in liters. Okay, our pi is given as 22 over 7 times our r is given as 1 meter. Since we have r squared, we have 1 meter times 1 meter times our height, which is our depth of 14 meters. 14 meters. So 7 into itself is 1, 7 here is 2. So we have 22 times 1 times 1 times 2 times 1 meter times 1 meter times 2 meters. We multiply 2, we have 44 meters cubed. This is the volume of that solid cylinder. But it is in meters cubed. We have to find the capacity in liters. It is in meters cubed, we have to find the capacity in liters. And remember telling us that any solid shape whose volume is 1000 cm cubed can hold liquid of 1 liter. But what we have here is not in cm cubed but meters cubed. So we first solve it by converting this to cm cubed before we can convert to liters. So in converting meters cubed to cm cubed, we have that 100 cm. 100 cm is 1 meter. 100 cm, we have 100 cm is the same as 1 meter. So for us to convert from in cm cubed, since 100 cm is 1 meter, we have 100 cm cube will give us 1 meter cube. That's the cube of this will give us 1 meter cube. 1 meter cube, like multiply this by itself 3 times. We multiply this one by itself 3 times. This will now give us 100 times 100 times 100. If you multiply, that gives us 1 million. There's 6 zeros. 1 million cm is the same as 1 meter cube. Now we can now convert 44 meters. 44 meter cube to cm cube. We say 44 times 1 million. 44 times 1 million cm cube. That's in converting from meters cube to cm cube, we multiply by 1 million. So when we multiply that, we have 44 million. We have 44 million cm cube. It is now at this point that we can convert to liters. It is now at this point that we can convert to liters. Remember, we say that 1000 cm cube is the same as 1 liter. That's any, as I said earlier on, any container that has a volume of 1000 cm cube can hold a liquid of 1 liter. So 1000 cm cube is the same as 1 liter. We now convert this to liters. So if we have that 1000 cm cube is 1 liter, for us to convert this to liter, we divide by 1000. So we have 44 million all over 1000. These 3 zeros cancel these 3. We are left with 44,000 liters. 44,000 liters. So you can hold about 44,000 liters. The cylindrical well can hold about 44,000 liters. After we got our volume as 44 meters cubed using the formula pi r square h, we now say that 100 cm is equal to 1 meter. 1 meter. Now for us to convert cm cube to meter cube, we find the cube of 100, which is 1 million. The cube of 100 is 1 million, and the cube of 1 meter is 1 meter cube. So we now have that 1 million of this is 1 meter cube. We now convert 44 meter cube, which is our answer, to cm cube. The reason is because we are to find the liters, the amount of liquid that cylindrical well can hold. And before we do that, we must first convert to cm cube by multiplying our meter cube by 1 million. And 44 times 1 million gives us 44 million cm cube. And we have already established the fact that 1000 cm cube is 1 liter. So, for us to convert our cm cube to liters, we divide by 1000. And that gives us 44,000 liters. So the cylindrical well can contain about 44,000 liters of liquid. Next, we have here to calculate the volume of the cylinder we have on the board. As you can see in the cylinder, we have a height of 4 cm and a diameter of 14 cm. So, our height is 4 cm, our diameter is 14 cm. So for us to find our radius, we should know by now that radius is half of our diameter, or diameter over 2. That's 14 cm all over 2, that's equal to 7 cm. And we have to find the volume of that cylinder. We have the formula pi r square h. Pi r square h. We have to use 22 over 7 as our pi. So we have 22 over 7 times our radius of 7 cm times 7 cm times our height of 4 cm. 7 to itself is 1. Here we have 1. So we are left with 22 times 7 cm times 4 cm. 22 times 7 gives us 154. 154 times 4, we have 616 cm cube. Cm cube. Let's go again. We have to calculate the volume of the cylinder of height 4 cm and diameter of 14 cm. Since we have a diameter to be 14, our radius is 7 cm. By dividing by 2, and we will apply a formula pi r square h for calculating the volume of our cylinder. We have 22 over 7 times our radius of 7 times 7, then times our height of 4 cm. 7 cancels 7. We are left with 22 times 7 times 4, and we multiply through to get 616 centimeter cube. That is our volume of the cylinder on the board. We have do these assignments on the board. A rectangular tank is 76 cm long, 50 cm wide, and 40 cm high. How many liters of water can it hold? We've done something very similar to that, so you should be able to do that with ease. We have the second one. I have a cylindrical tin full of engine oil, having a diameter of 12 cm and a height of 14 cm. The oil is poured into a rectangular tin of 16 cm long and 11 cm wide. You have to find the depth of the oil in the tin. Please ensure to do this assignment. For some time now, I've not been seeing your assignments, so I want to encourage you to do this one and submit as soon as possible. See you next week. Goodbye.